Hello, this is Mrs. Myers, and I'm going to just do this review sheet for the honors geometry practice for the coordinate geometry test. I'm going to go through as many of these as I can. Find the coordinates of the midpoint of AB. Midpoint formula, remember, we are going to add the x's, so 10 plus negative 3 over 2, and add the y's. Negative 4 plus 14 over 2. You're going to get 7 over 2, which is 3.5, and 10 over 2, which is 5. Don't forget to put those parentheses around them. The coordinate of y is negative 2, negative 7. The midpoint is 6, negative 10. Find the coordinates of the other endpoint. Remember, we had that quick way of doing things. If you do negative 2, 7, and then the midpoint underneath that, I'll do that in a different color, 6, negative 10. And then your missing coordinate goes underneath that. Figure out what it takes to get from negative 2 to 6. Negative 2 to 6 would be a plus 8. And negative 7 to negative 10 would be a minus 3. So if we added 8 to get from negative 2 to 6, we have to add 8 again to get from 6 to the new coordinate. So it would be 14. And then negative 10 minus 3 again would be negative 13. So that's your new endpoint. Point x would be 14, negative 13. The distance between C and D, distance formula, we are going to subtract the x's, subtract the y's, square them, add them, take the square root at the end. So subtract the x's, negative 9 minus a negative 3 makes it a plus 3, and subtract the y's, 4 minus a negative 5, so it's a plus 5. Negative 9 plus 3 is negative 6 squared, and 4 plus 5 is 9 squared, so we have 36 plus 81. This is the square root of 117, which simplifies, get 9 and 13. 9 is a perfect square, goes into 117 13 times, so this is 3 root 13 as your final simplified radical. Find the slope of the line. So this is just practicing all of these formulas. Negative 6 minus 3. Difference in the y's on top, negative 1, minus 2, difference of the x's on the bottom, that's negative 9 over negative 3. Negative over negative is a positive, so it's a positive 3. Number 5, graph the line. This is point slope form. So here's my slope, and the point that we're going to start at is negative 3, negative 2, right? We take the opposite sign, x, y. So negative 3, negative 2. Here's my xy axis. Negative 3, negative 2 is here. And then I'm going to count my slope of negative 4, down 4, to the right 1. So your line should go something like this. It goes through the point negative 3, negative 2. Use the given information to write the equation for the line. If it goes through these 2 points, remember, if we're writing an equation, the very first thing we always need is the slope. So we're going to do difference in the y's on the top and difference in the x's on the bottom. Negative over negative is a positive. This is a slope of 1/2. If it goes through this point, I'm going to use point slope form. Y minus 2 equals slope, which is 1/2, times x minus 10. If I want to write this in slope-intercept form, I'm just going to solve for y. So y minus 2 equals 1/2 x minus 5, because 1/2 times 10 is 5. Add 2 to both sides. My final slope-intercept form would be y equals 1/2 x. Negative 5 plus 2 is negative 3. That's my final answer there. Number 7, graph the pair of lines. When we have one line is y equals and one line is x equals, one's horizontal, one's vertical. This one is horizontal because it goes through the y-axis at negative 5. And this one is vertical because it goes through the x-axis at -2. The point where they intersect, of course, is going to be the point -2, -5. X is -2, y is -5. Are the following lines parallel, perpendicular, or neither? So we need to compare slopes to be able to determine this. You might use the slope formula, or you might just count the slope. If I want to get from this point to this point, I'm going to go down 4 and to the right 2. That's a slope of -2. And to get from this point to this point, I'm going to go down 1, 2, 3, 4, 5, and to the right 2. That's -5 over 2. Not the same slope, not perpendicular, opposite reciprocals, so neither. And these two, we are going to count the slope again. I could use slope formula, but I'm going to count down 1, to the right 1, 2, 3, 4, 5, 6, so -1/6. And the slope of the other one is from here to here, is down 1, 2, 3, 4, 5, 6 to the left 1. So down 6 to the left 1 is -6 over -1, which is a +6. We could tell this is going up, so that's a positive slope, and this is going down, so that's a negative slope. So these are perpendicular because they're opposite reciprocals. This one I can see the slope right away is -5/2. Here I can't tell right away. It's almost in slope-intercept form, but not quite yet. So I have to divide everything by 5. I get y equals 2/5 x plus 6/5. So here I have a slope of 2/5, and here I have a slope of a -2/5. So again, -5/2. So opposite reciprocals make perpendicular slopes. Okay, equation of the line perpendicular to AB that contains point C. That's going to be perpendicular to this, means I need a slope of the opposite reciprocal of 2, so that's -1/2, and it's going to go through point C. Again, I'm going to use point slope form. Y minus 5 equals -1/2 times x plus 6. When I simplify this into point slope form, we're going to get -1/2 x minus 3, add 5 to both sides, and you get y equals -1/2 x plus 2. Number 12, the vertices of a triangle are given. Plot the points on the coordinate plane and determine whether the triangle is a right triangle. Okay, I'm not going to plot these points because you guys would be able to plot those on your own. You could count the slope if you plot them, but I'm going to show the slope formula this time to see if it's a right triangle. Slope of TR is 0 minus 4 over -1 plus 2, -4 over 1. Slope of RI is 5 minus 0 over 2 minus a -1, which is plus, so 5 over 3. And TI is going to be 5 minus 4 over 2 minus a -2, which is 1 over 4. So I can see these are opposite reciprocals, so yes, it's a right triangle. Okay. Is this scalene, isosceles, or equilateral? Here we're going to need distance formula, the length of TV, the length of VS, and the length of TS. You know what? I have those answers on the answer sheet, so I'm going to skip through so I can explain more that needs to be explained here. Number 14, a quadrilateral has vertices given, SNOW. Show that the equilateral that is formed by connecting the midpoints is a rhombus. Okay, so here's a hint. You can show that it's a parallelogram with perpendicular diagonals, or you could show it's a parallelogram with all four sides congruent. So you have some choices here. Point S is at 5, 3. Point N is at 5, negative 1. Point O is at negative 1, negative 1. And point W is at negative 1, 3. No more snow, please. Okay. And to connect the midpoints, we're going to need the midpoint formula first. Because that's what this says, what is formed by connecting the midpoints. I'm going to call this A, B, C, D. So here we would use the midpoint formula to find point B, which is the midpoint of WS, right? So we're going to use the points from W and S. Add the x's, 5 plus negative 1 over 2. Add the y's, 3 plus 3 over 2. This should become 4 over 2, which is 2, and 6 over 2, which is 3, which makes sense because it looks like that point is at the point 2, 3. Okay? So we could do the midpoint formula for all of these. We could also, since it's graphed, kind of figure out what these are. A is going to be negative 1, 1. And D is going to be 2, negative 1. And C is going to be 5, 1. We need those coordinates to prove that this is a rhombus. So I always feel like the best way to prove something is a quadrilateral of a specific type is to always start with all four slopes. It's not always the fastest way, but it's a way that will work every single time. So I'm going to find the slope of AB, BC, CD, and AD. This is right away going to tell me if this is a parallelogram. So the slope of AB is 3 minus 1 over 2 minus a negative 1, which is 2 over 3. Slope of BC is 3 minus 1 over 2 minus 5, which is 2 over negative 3. CD is negative 1 minus 1 over 2 minus 5, which is negative 2 over negative 3, which is a positive 2/3. And AD is 1 minus a negative 1, which is plus 1, over negative 1 minus 2, which is 2 over negative 3. So we have these two are parallel, and we have these two are parallel, which makes it a parallelogram. Now I can show that it's a rhombus. Maybe I want to do perpendicular diagonals. That would require doing the slopes of the diagonals. Well, if you look at your diagram, the diagonals are going to be BD and AC. So if I'm going to do the diagonal BD, I'm going to use these coordinates to find the slope, which is 3 minus a negative 1 over 2 minus 2. Slope of BD, yes. So BD, it's not surprising that it comes out to something over 0 because that makes it undefined, which signifies that it's a vertical line. AC, if we do the slope, it's going to be 1 minus 1 over negative 1 minus 5. Again, we have 0 over something. That's 0. That means a horizontal line and a vertical line, which are perpendicular to each other. So that makes this a rhombus with perpendicular diagonals. A parallelogram with perpendicular diagonals, which makes it a rhombus. Okay, determine the most precise name for the quadrilateral with the given vertices. Use the appropriate formulas to prove your answer. Write a summary statement explaining your conclusion. So A is at -5, 0. B is at 2, -6. C is at 8, 1. And D is at 1, 7. So this is A, B, C, D. We're going to try to prove it is what it is. Again, I always like starting with all 4 slopes because then right away I narrow it down to what it might be. I get slope of AB. Here I'm using these coordinates, AB, -6 minus 0 over 2 minus a -5. That's -6 over 7. For CD, I'm expecting CD to be the same slope as AB if it's a parallelogram, so I'm going to do that one next. CD is 7 minus 1 over 1 minus 8. That's 6 over -7, which is -6/7. I'm going to do BC. BC, 1 minus a -6 over 8 minus 2 is 7 over 6. And then AD is 7 minus 0 over 1 minus a -5, which is 7 over 6. So I get that these two are parallel, and I get that these two are parallel, but might also notice that these two are opposite reciprocals of each other, so they are perpendicular, as are these two, as are these two, as are these two. So I have a parallelogram with 4 right angles. Which means it's either a square or a rectangle. I have to do some further calculating to figure out which one it is. If it's just a plain old rectangle or if it's a special square. So I'm going to do the distance formula for the 2 sides. You could do the diagonals to see if they are perpendicular to each other, because that would be true about a square and not of a rectangle, because the square is a rhombus, right? But I'm going to do distance. I'm going to do the length of DC and the length of CB. Okay, so the length of DC is going to be DC. I'm going to subtract the x's, 1 minus 8 squared plus 7 minus 1 squared. That's -7 squared plus 6 squared. That's the square root of 49 plus 36. And so CD is the square root of 85. Then I'm going to do CB. I'm going to do the same thing with C and B. 1 minus a -6 squared plus 8 minus 2 squared. Again, I get 7 squared, and 6 squared is the square root of 85. So this is going to be, in fact, a square. Okay, I need a summary statement. I would write, since the opposite sides are parallel and consecutive sides are perpendicular, we have a parallelogram with all right angles, and since consecutive sides are congruent, we know we have a square. Okay, now we're getting into the last section here, 6869. This is where like part 2 of the test is going to start testing. Find the missing coordinates in terms of the given variable. Let me make a big 2 here because this is where part 2 starts. ABC is a right isosceles triangle. This clearly goes up K and down K, so this whole side must be 2K. So that means my coordinates for C, I'm going to go over 2K and up K. Because I want this it's isosceles, I want this to be the same as this. So if this is 2k, this has to be 2k. So I'm going to go over 2k and up k, because this was just k, right? Okay. Part B, ABCD is a square. This goes up p and down 2p. So what's the entire side? 3p. Therefore, coordinates of B, if it's a square, I have to make this side the same as this side. So this has to be 3p. So I'm going to go over 3p and up the same amount that I went up here. So that's p. And then C is going to be again over 3p, and this time down the same amount I went down there. So that's negative 2p. 3p, negative 2p. Okay. Here we've got a rhombus. It says a rhombus. I know I went over P and up Q. And that means this has to be P and up Q. So for F, it's going to be Q there. Here I'm going to go over. This one requires the distance formula. This one's a little bit tricky, and I don't think I would put this on the test. So this one's a little bit trickier. Yeah, I'm going to say skip that one, because I would do that if we had more time, but I think that I won't put something like that on the test. Okay, if possible, give the coordinates of the unknown vertex or vertices without introducing any new variables. If it's not possible to not introduce a new variable, then you have to pick another variable. Okay, so for B, this would be negative A. This would be negative A, and D would be over A down A. Again, a square over A up 0. This is going to be over A up A. This is going to be over 0 up A. And M is just 0, 0. Isosceles triangle, if we go over A and up 0, that means we have to go back A and up 0. Number 4, we've got negative A, 0, positive A, 0 for Q. R is over B up C, so this distance must be B. So that means I'm going to go back the same distance to get to S. Back B, up C. Number 5, since I have for F, I've got negative B. That means this distance is B. So this distance has to be B if it's a parallelogram. And up C. So D is over A up 0. So this whole distance here is A. This little distance here is B. That means the coordinates of E is going to be A minus B, and then up C. G is obviously 0, 0. Okay, equilateral triangle. This has to be the same length on all sides. Again, this is going to require distance formula, so I wouldn't put one like that on the test, so don't worry about that one. Okay, we're going to go on to the next. The fact that the diagonals of a kite are perpendicular suggests a way to place a kite in the coordinate plane. Show this placement. Include labels for the kite's vertices. So since the diagonals are perpendicular, I could place a kite so that the diagonals cross right at the origin. That makes them perpendicular. Now we had one like this in a homework before. This distance has to be the same as this distance. So maybe you're going to go over 0 up A and over 0 down A. Right? And then this distance back this way has to be different. So maybe back B up 0. And then the one over here has to be even different than those. So maybe over C up 0. Okay? In the coordinate plane, draw a square with sides 4q units long. Okay, Well, I'm just going to do a square right at the, remember we're not using numbers here, we're using variables, so don't let the boxes on the grid make you think of numbers. This is just helping you place it so that you know the distances you're going. Might be better not to have the grid there, but it's there. So we're just going to use for Q, we're not going to use numbers. So this is going to be over 4Q up 0. That makes it a length of 4Q. This one's going to be over 0 up 4Q. And this one's going to be over 4Q and up 4Q. So the coordinates of each vertex, this is 0, 0, and the coordinate of the point of intersection of the diagonals. So if I find the point of intersection of the diagonals, these should bisect each other, right? So I should be able to get where they intersect, it's going to be the midpoint. So I'm going to do midpoint of, let's call this A, B, C, D. I'm going to do the midpoint of CA first. Add the x's for Q plus 0 over 2. Add the y's for Q plus 0 over 2. I get 2Q, comma, 2Q. Midpoint of BD, I should get the same thing. 0 plus 4Q over 2, and 4Q plus 0 over 2 is going to give me 2Q, 2Q. Okay, if you want to prove that the diagonals of a parallelogram bisect each other using coordinate geometry, how would you place the parallelogram on the coordinate plane? Give the coordinates of the vertices for the placement you choose. We can place a parallelogram a bunch of different ways. Since we're proving that the diagonals bisect each other, I don't think that's going to affect how you place it. You could place it however a parallelogram makes sense. Oops. Remember that the key for a parallelogram is that this distance has to be the same as this distance. That's what makes it a parallelogram. So my placement here, I'm going to, let's make this A, B, C, D. Point A, I'm going to go back A up 0. For B, I'm going to go over 0 up B. Now I've got to decide about C and D. I have some choices here. If I make this length C, then the coordinates of D are going to be C, comma 0, over C up 0. And then the coordinates of C, I'm going to have to go over C plus B. I'm sorry, over C plus A, right? Because this distance is A, and it has to be the same as this distance is A. So to get to point C, I have to go over C plus A, and then up B. Now again, there's other ways of doing this. You should check your answers that are posted on that the website about the practicing coordinates. It's posted. Remember we did 2 ways of doing a square, 2 ways of doing a trapezoid, 2 ways of doing a parallelogram. That worksheet, the answers are posted, so you can check that. Okay, prove that this is an isosceles triangle using a coordinate proof. Okay, remember with coordinate proofs, we are going to show what formulas we're using. So to prove that it's an isosceles formula, isosceles triangle, we're going to use the distance formula to find the length of each side, AB, BC, and AC. Once you get the distance formula, we're going to figure out that it's isosceles. Hopefully 2 of these will come out to be the same length. That's what will prove that it's isosceles. 2 sides the same. Okay, so AB, I'm going to subtract the x's and square them, and subtract the y's and square them. I get a squared plus b squared. Can't simplify that, remember. BC, 2a minus a plus 0 minus b. Again, I'm going to get a squared and b squared. Already we know it's isosceles because those two came out the same. Let's do AC just for kicks here. 2a minus 0 plus 0 minus 0. This actually comes out to 2a squared and then the square root. So it's just 2a. So that one's not the same length. These two are the same length, therefore it's isosceles. Again, with a coordinate proof, you need a statement. Since AB equals BC, then triangle ABC is isosceles. Alright, 22, write a coordinate proof of the following theorem. If a quadrilateral is a kite, then its diagonals are perpendicular. So we practiced placing a kite before. This coordinate proof, you're in charge of the naming the coordinates. So, in order for your algebra to work out, you got to make sure that you pick coordinates that make sense to the shape that you want. This is a kite, so I'm going to go over 0, up A, over 0, down A, back B, up 0, positive C, up 0. Those are my coordinates. Prove that its diagonals are perpendicular. Okay? For perpendicular, I'm going to need slope of the diagonals. So slope of BD, slope of AC, slope of BD, A minus a negative A over 0 minus 0. That's 2A over 0. That's undefined. Slope of AC, 0 minus 0 over C minus a negative B. That's 0 over C plus B, which is 0. One is horizontal, one is vertical. These are perpendicular. So, sentence. Since slopes of the diagonals are opposite reciprocals, they are perpendicular. Okay, prove the midpoints of the sides of the rectangle. Prove that the midpoints of the sides of a rectangle form a rhombus. Okay, so I have to place a rectangle and then find the midpoints to get it to be a rhombus. So again, I could put my rectangle here. I could put it here. I could put it here. Okay? You got to choose which way you like it the best. I like nestling it into the corner personally, so that's what I'm going to do. I'm going to have 0, 0 as one of my points. Now, if this is a rectangle, let's call this A, B, C, D. If this is a rectangle, I'm going to go up a certain distance and to the right a different distance. So I just need two variables here. Maybe I'm going to go over 0 and up B. Over here, I'm going to go over A and up 0. So this distance is A, this distance is B. So C, I have to go over A and up B. Those are the vertices of my rectangle. Now I need to find the midpoints of the sides. And see if this is a rhombus. So let's call these X, Y, Z, W. All right, so the midpoint of, I need the midpoint of BC. I'm going to call that point Y. Midpoint of BC, I'm using the coordinates for B and C, A plus 0 over 2, and B plus B over 2. Midpoints. Oh, at this point, this is when you say to yourself, shoot, I should have doubled everything. Should have doubled everything. Okay, so let's double everything. 0, 2B. And I'm literally doubling everything. 2A, 2B, 2A, 0, and 0, 0. All right, that's going to be a little nicer. 2A plus 0 over 2. 2B plus 2B over 2.
Molly, DeAndrea, please call the main office. Thank you.
Oops, sorry. I tried to pause for that announcement, but I missed it. Okay. 2A over 2 is A. 2B plus 2B is 4B over 2 is 2B. So that's the coordinates of Y, which is the midpoint of BC. Now I'm going to do the midpoint of CB, which we're calling Z. And again, I'm going to add the x's. 2A plus 2A over 2, and 2B plus 0 over 2. This is 4A over 2, which is 2A, and 2B over 2, which is just B. Midpoint of a, oh shoot, I meant CD here. CD, I read this as a B, but that's actually a D. Okay, so that was CD. Now we're doing DA. DA. Midpoint of DA, which we're calling point W. And again, we're going to add the x's, 2A plus 0 over 2, and 0 plus 0 over 2. We get the point A, comma, 0. Then we are going to do our last side, which is AB. Midpoint of AB, we're calling X. Add the X's, add the Y's. You get 0, comma, B. Those are our coordinates of the supposed rhombus. We're trying to prove now that these points make a rhombus. I didn't write small here, but again, I like to at least start with slopes because that automatically shows that it's a parallelogram or not, right? So I'm going to be doing slopes. Could do this differently, remember. You could do the diagonals bisect each other first to show it's a parallelogram, and then prove it's a rhombus because the diagonals are perpendicular. In fact, let's do that because we already did one with all 4 slopes. So let's do it a different way this time. Let's do diagonals bisect each other. I'm going to say question mark because this is going to show, is it a parallelogram? Remember, one of our ways of proving something is a parallelogram is to see if diagonals bisect each other. So diagonals in this case are going to be XZ and YW. So if we're trying to figure out if they bisect each other, we need the midpoints of XZ and YW. Midpoint of XZ. Well, remember, here's X and here's Z. So those are the 2 coordinates that we're using to find midpoints. We're going to add the x's, 2A plus 0 over 2, and add the y's, b plus b over 2. We get 2A over 2, which is A, and 2B over 2, which is B. So the midpoint is AB of one diagonal. Let's do the other one and see if it's the same. If it's the same, we know they bisect each other. So now we're using this set of coordinates. Again, we're going to add the x's and add the y's, divide by 2. we get 2a over 2, which is a, and 2b over 2, which is b. So, same midpoint. So, diagonals bisect each other. Therefore, this is a parallelogram. Now, we're asked to say whether it's a rhombus or not. Now we would have to show that the diagonals are perpendicular. So now, the question is, are the diagonals perpendicular? Because that would show that it's a rhombus. So we're going to, for perpendicular, we need slope of the diagonals x, z, and y, w. Slopes this time. All right, slope of x, z. Here we're using these again. Subtract the y's on top. We get b minus b over, it doesn't matter what it's over because this is 0. And then for the slope of y, w, we've got y and w. Subtract the y's on top, 2b minus 0 over a minus a. 2b minus 0 over a minus a, well, that's 2b over 0. This is undefined. And these are perpendicular. I know I didn't write very small here, but so since diagonals bisect each other, it is a parallelogram. And since diagonals are perpendicular, the parallelogram is a rhombus. All right, I know that was a long video, but I wanted to make sure everything was explained for preparing for the test. Okay, good luck.